Hello class. This time I'll be simulating, um, just to give you an idea on how to use LTSpice, I'll be simulating the RLC circuit. Okay, let's start. So go to file, then new schematic so that you can draw your schematic. Okay, then click this symbol, just like the AND gate, but that's actually for the component. Okay, so you just click that. Then as you may have noticed, we need a voltage source, a resistor, inductor, and capacitor all in parallel connection. So for that, let's have a voltage source, so voltage. Then let's also have, so in order to get away with this voltage source going along your cursor, just press the escape key in your keyboard. Okay, so there, it's gone. Then again, go to component, find the resistor, so res. Okay, then escape, press component again, find the inductor here. Okay, so then lastly, press escape, find the capacitor. So okay, so that's how you place your components. Now I want to show you some shortcuts. In order for, if you want to choose a voltage source, just the shortcut is just to press the V key in your keyboard. So just press V, and there, it automatically pops up. Okay, so just click. Then no need to press the escape key. Just press R for your resistor, and there. For inductor, just press L. Then for capacitor, just press C. Okay. And then you have it. Then press escape. Now, in order to know other shortcuts, just click edit and you'll have a list here of the shortcuts. One important shortcut is this one, draw wire. Then the ground and drag or move. Okay, so for now, let's draw the wire. In order to zoom out and zoom in, just use your mouse wheel. Okay, so I press F3, and there, that's the cursor for our wire. Okay, so I'll connect the components together. Then in order to delete components, just press delete in your keyboard. So there's a scissor, so delete. Okay, then press escape. Okay, now V2, R2, L2, and C2, these are called reference designator. That is, LTSpice uses these values in order to identify these particular components. V, R, L, and C, this is your value. So for now, I wanted to call C2 as C. Okay, so wait. So just right click on its name or reference designator, then I want it to be C. So okay, then its capacitance, as you have seen from our, this is 10 microfarad, 100 millihenry, and 100 ohms. So this should be 10. Okay, you can put E to the -6. You can also put 0.00001, okay, for 10 microfarad, or you can just put 10 U. Okay, U for microfarad. Okay, then okay. For our inductor, it should be 100 millihenry, so 100 milli. Okay. The Henry part is already understandable because LTSpice assumes that the inductance, the units for your inductance is H or Henry. Okay. Then the reference designator, I want this to be L. Then for your resistor, let's have R. Oh, it should be R1, sorry. It should be R1 because um oh no, I think R, okay, it won't do because you already have R1 here. Okay. Reference designator, let's just use R. Then value 100. Then for our voltage source, the default setting for your voltage source is a DC voltage source. Okay. But in order to access other kinds of sources, you go and click advanced. Then you have it there, the AC voltage source. We have zero offset. Our amplitude is 10. It's mentioned here. It's 10. The amplitude is 10 and the frequency is 60. Okay, so frequency is 60. No delay. Okay, just don't fill that up. Our no phase angle, zero phase angle. Okay. Then we are to make an AC analysis. We use the AC analysis if you want to dwell with phasor calculations. Okay. But if you want time domain analysis, then we go to transient. Okay. But since we will be on phasor, so we also have to fill up this AC amplitude, that is 10. AC phase is 0 since this is the 10 volts voltage source is our reference voltage. Then click OK. Now, you may have noticed that this label overlaps your resistor. So just press F8 in order to drag. Okay. And as you may have noticed, it's just the same symbol. Okay. So drag, click, click, then click to drop. So you have it there. Now, I want this to be your VS. Okay. And I also want to designate this node as VS. Okay, so for that, you can just add label. Okay. Then write VS. Then don't forget your ground. Otherwise, LTSpice will run an error. So there you have the ground. And for that, well, run the simulation. Then transient if you want time domain analysis. AC analysis if you want phasor domain. So for the phasor domain, since in the problem we are asked with here the phasor magnitude and phase, so will be on phasor domain. So for the sweep, just choose linear. Number of points, we only wanted 1 point. Start frequency, we are not changing frequency, so it's just 60. Stop is 60 still. Okay, then click OK, and there it is. LTSpice immediately gives the answer. So VS has a magnitude of our voltage at node VS. Okay, our voltage for VS, okay, is 10 volts. Angle -5 e to the -15, that's basically 0. So 10 angle 0, which that's because it's our reference. IC, it's this one, 0.037 with a phase of 90. Okay. We expect that, di ba? We know that a capacitor, in a capacitor, the current leads the voltage. Then for an inductor, the current lags the voltage. So that's why our phase here is negative 89.9985. So basically it's negative 90. Then our resistor, as you may have noticed, they have the same phase. and that corresponds with that agrees with what we know, that voltage and current are in phase through a resistor. Then this is the current of our voltage source. Okay. Okay, so there you got these values immediately.